This in cadaver. No, it was you guys, yeah. So we don't need to cover the mediastinum. Myocardium, endocardium. Okay, visceral pericardium is the epicardium. So what happened is these sheep had been removed from, or the sheep parts had been removed from the mediastinum, and what we're looking at right now is actually visceral pericardium. Okay, which is the same thing as epicardium. You with me? Mm-hmm. So if we open this up, you look at this one, you can see this would be epicardium and visceral pericardium, myocardium, and then all this tissue in here is the endocardium. Endocardium is its main function, specific, in that its job is to help prevent blood from adhering to the structures, okay, or from the structures on the inside of the chambers. So next thing, pericardium, pericardial sac. We don't have any of the pericardial sac left over. Actually, there is some right here. So this is some of the pericardial sac left over. Okay. See it right here. Right, that's pericardial sac. See how tough and fibrous that is, right? Question?
Oh, it's thicker than I was thinking.
It's thick. Remember I said before, it's got a pericardium to it, but it's also got that outer fibrous layer. That's non-expansile. It doesn't expand. Okay, next thing. Covered that. Visceral pericardium, myocardium, endocardium. Coronary blood vessels. You're not going to really see a good shot of the coronary blood vessels here, but I will show you where they lie. For instance, these are coronary arteries coming down. You can see them going down here. You can see them setting there. If we flip it over on the back side, you can also see where they reside. Now, you'll notice with these vessels is a lot of fat. See that there? See how the vessel comes down here? There's a vessel under here, vessel under here. Those vessels are surrounded by fat. And everybody always asks, well, why is that? Because it doesn't make sense that you would have a lot of fat with these vessels, because isn't fat what helps to clog these vessels to create coronary artery disease? And the answer is yes. So there's a dichotomy here. We got a problem with our catch-22. We've got a problem with the fact that fat has a tendency to collect in these vessels because it's adjacent to the vessels. But then the question is, why is the fat there? Anybody have an idea?
Stability?
No, good guess though. Well, a lot of people think protection, and that's, yeah. So the main reason why is, think about this. This is the only muscle in the human body that has to work all the time. This is truly your aerobic muscle, okay? And if you're into working out, you know that best way to burn fat is to do aerobic workouts, right? So fat needs to be accumulated in these areas because fat is the main energy source for the heart muscle tissue. All right? We don't have a lot of glycogen here. Glycogen is found in the liver and in the muscles. When I say muscles, I mean skeletal muscles. What we have a large fat supply here because we need it, because that muscle is the epitome of an aerobic muscle. Okay. Next thing, left and right atria. So the atria are the two upper chambers. So if we look right here, you can see this is. So let's get our bearings. The left side of the heart has a very thick wall to it. The right side of the heart has a relatively thin wall. Why? Because the right side of the heart, the right ventricle, has to pump blood to the lungs. The lungs are right there. Very little resistance to blood flow to the lungs. So the wall of the right ventricle can be very thin. The left ventricle, on the other hand, has to pump blood all the way to the head and all the way down to the feet. So this has got to be much thicker to overcome the resistance of pushing blood all the way through the body and then getting that blood to come all the way back to the heart. So left side, if you open this up, the way you get your bearings, this is called the interventricular septum. And then this is the wall of the left ventricle. This is the wall of the right ventricle. This is the wall of the left. This is the wall of the right. So ventricles down below, ventricle here. The atrium, the right atrium, is this structure right here. So we come up on this side. Where my thumb is the right atrium. Okay? This one's going to be the left atrium. Alrighty? So now we covered that. The two ventricles, we just talked about those. Left ventricle, right ventricle, left ventricle, right ventricle. Auricle. Auricle, A-U-R, means ear or flap. as opposed to OR, which is a soothsayer, like the Oracle in the Matrix with Keanu Reeves, right? He's a great actor, let me tell you. So that's an oracle. That's an ear. That looks like an ear, doesn't it? It's an ear flap. So that's one oracle. And then here's the other oracle on the other side.
What's the purpose for those?
They're like accordions. There's always a question, what's the purpose? But we think they're almost like a little bit of an accordion. They will open up when the atria fill up more with blood, and then they'll collapse more when they're not. Okay? There's a little, if you can feel, when you get a chance, you'll be able to feel there's a little bit of a pocket, a small pocket in that oracle.
Are they bigger in athletes? Do you think it has something to do with like athletic ability?
No, for athletes, we usually see a larger left ventricle. We call it left ventricular hypertrophy, which is also known as, quote, athlete's heart. Okay? Because an athlete needs to be able to pump a lot of blood to the peripheral muscles. So the left ventricle is the one that does that. So it has a tendency to get to becoming large. Okay? Oracles. Pulmonary trunk. All right, so the pulmonary trunk is going to come out of this dude. Okay? The pulmonary trunk goes from the right ventricle up to the lungs. The way to find this, if I flip it like this, the right atrium and ventricle is on my left side, which is the way we typically want to see it. But how do you find the pulmonary trunk? Flip the other direction, and then you're going to take your finger and slide it up into this space, and you'll see they've already cut this. Okay, they've already cut so you can look in there. The pulmonary trunk is actually this vessel right here along that cut. So that's pulmonary trunk. Remember, the pulmonary trunk goes to the lungs. I don't know if this one has it, and if it doesn't, that's okay, because what I want to do, so remember, this is the right side, left side. I flip it over, so the right is on the right, and I stick my finger up in here, and eventually I'll be able to get through to the pulmonary trunk. They did cut this, but this is pulmonary trunk, this vessel right here. Okay? Mm-hmm. So if you have a question, you want to find out what you're looking at, you go, as I said before, right atrium on this side, go up in there, and that's where or right ventricle on this side, go up in there, and that's where the pulmonary trunk is.
So it's posterior?
Yeah, well, no, it's actually kind of more anterior. What happens is, so this is anterior, okay, that's the front of the heart. That's pulmonary trunk coming up right there.
Okay,
right?
okay.
That dude right there. So pulmonary trunk kind of comes up like this. Aorta goes up like this. Aorta comes like this and across and up and then down. The problem is that most of these vessels have been cut so close to the heart that it's hard to find out which one's which. But we'll do our best here. So, which leads us to the next one, which is the aorta. So the aorta is coming off the left ventricle. So if we look at this, this is left ventricle, that's left ventricle. This is the left atrium up above, okay, left atrium up above. So what happens when the left ventricle contracts, it's not going to send blood back in the other direction, it's going to send blood up in this direction. So this right here, this hole right there, that's going to be a hole for the aorta. And if you look at this, you can see there's the ascending aorta right here. If you look in, you can see, I'll stick my finger up a little further so you can see it. You can see my finger pointing out of the aortic arch. That's the aortic arch. And then this dude right here is what we call the brachiocephalic trunk. That's coming off of the aortic arch and going to the right side. Brachiocephalic. That means it's going to the arm and to the head, right? So we'll have the right common carotid coming off of this, as well as the subclavian going down into the arm. So, pulmonary veins. Now, pulmonary veins are usually cut very close. Pulmonary veins are going into the left atrium. They're usually cut very close to the left atrium. Let's fold this up so you can see this is the left ventricle. Left atrium is up in here, and I can see those holes for the pulmonary veins on the back. This is the back of the heart. Okay, let's show you this one as well. See it right there? So these are all pulmonary veins coming from the lungs back to the left atrium. All right? back side of the heart, pulmonary veins up here. Okay? All right, next thing, what do we have next? All right, so we got the tricuspid valve next. So the tricuspid, remember, that was located between that was on the right-hand side, between the atria and the ventricles. So the tricuspid valve is this dude, right? So this is the right side, thin wall, okay? This is one of the tricuspid valve cusps right here. You can see it. I'm lifting it up. See it right there? So this is going to be right ventricle. This is up in here is going to be right atrium. The cusp, that's the cusp right there. And you can see these are the chorda tendineae. See them right there? Parachute cords. And then this projection right here would be a papillary muscle. All right? That is right atrioventricular valve. Okay? And then we've got the pulmonary semilunar valve. So the pulmonary semilunar valve, we got to go back to the pulmonary trunk. So what did I do? Remember, to see pulmonary trunk, I flipped it this way. And I went up inside here to get to the pulmonary trunk. Now they did a good job cutting this, so you can kind of see the valve cusp down in there. Remember, the pulmonary semilunar valve is a semilunar valve cusp. It's not these with the chorda tendineae. So when I come up in here, I'm actually putting my finger through the valve cusp. And let me pull my finger out so you can kind of see. Now, not all of you can be able to see this. Probably Kristen and maybe Susanna would be best to be able to see this. But the valve cusps are these little dudes right here. Hard to see them. I know you can't see them over on that side. But they're going to sit down in here. We'll see if we can show you a better shot of, let's say, well, let's just do it now. Let's do aortic semilunar valve cusp. So this is the left ventricle. We come up through here. We go to the aorta. And the aorta has its own valve cusps. There's a little bit of a cut right here. That's part of the valve cusp there. As well as this right here. That's a really classic. See how it looks like a little pocket? There are 3 of these pockets. This one's been cut. This one's still intact. That's one valve cusp. And then this is the other one on the other side. Remember when I fold it back down together? Those 3 pockets come together to catch the blood and close. So there's one valve cusp, there's another valve cusp, and this is the 3rd one that's been cut. All right? Interventricular septum, we talked about that. Coronary sinus. So in order to find the coronary sinus, we need to go up into the right atrium again. The coronary sinus is, so here's the thing. The coronary arteries, their job is to send blood to the heart muscle tissue. Because the heart muscle tissue needs blood, doesn't it? Then, so we're sending oxygenated blood to the heart. Does that heart then need to take the blood from the heart muscle tissue and send it somewhere after we've given off all the oxygen? Yeah, so if we send blood to the heart, we got to take blood away from the heart. Agreed? Mm-hmm. So the coronary arteries, you've heard of someone having a coronary or coronary bypass surgery. Those are the arteries that go to the heart muscle tissue. The cardiac veins are the veins that take the blood that's been to the heart and then send it actually back to the heart again. Okay? So the coronary veins, cardiac veins, excuse me, they all collect back in this thing called a coronary sinus at the right atrium. So let's find the right atrium again. This is the right side, thin, right? Thick, left side. Right side is thin. So this is the ventricle down below. We want to go up into the right atrium. And I don't know if you can see this. Let's see if I can stick my finger up. This is where the superior vena cava comes out, going upward. Okay? All right. So we're going to try to do our best to show you this. Kristen, if you look, you can kind of see there's a hole right here. And maybe some of you asked to see yours, but see that hole right there where you can see through it? See the light? Y'all see the light back there too? Okay? Right next to that hole is another hole down in this direction. So I'll stick the probe up through the hole. There it is. But I'm going to go right through here, right next to that hole. And that's the coronary sinus. So now, if you look in there, grab me another probe, please. Yeah. Back there. Thanks, John. Thank you, sir. All right. So this probe is through the coronary sinus. The other probe I'm going to stick up through here is going to be through the superior vena cava. So that's superior vena cava right there. And then the coronary sinus is actually just below it, another little hole, but watch where it goes. It's coming along. See the back of, see that right there? See that? Now that's in the hole. See that right there? See the probe running against that? That's the great cardiac vein that drains into the coronary sinus. Where does it go? It drains into the right atrium. Well, where does the main blood from my picture over there come from the rest of the body? It comes from the upper part of the body into the right atrium, the superior vena cava. It comes from the lower part of the body, the inferior vena cava, into the right atrium. So that's all unoxygenated blood going back to the right atrium, right? So it makes sense that the unoxygenated blood from the heart goes back to the right atrium as well, correct? So that's called the coronary sinus. So again, superior vena cava is right there, and then just below it, right there, is the coronary sinus. And if we look along the back, there it is. We know we're in the coronary sinus. That's coronary sinus right there. Great cardiac vein in the coronary sinus. What's the difference between those? Well, if I had a trumpet, all of the tube would be the cardiac veins, and where it flares open, where all the air comes out, that big open flare would be the coronary sinus. Okay? So then that there is the great cardiac vein going into the coronary sinus, and all I have to do is just go straight up, pull out, go straight up, and now I'm in the superior vena cava. All right?
So on the test, how would you ask us for the coronary sinus? Would you have that probe in there?
We'd probably put a probe in there. It's kind of tough to do because what we don't want is everybody messing with this stuff, right? So, but if you look at a schematic of these, what you'll see when you look in the right atrium, you'll see the upper hole, you'll see a big upper hole, a big down lower hole. That's the inferior vena cava where it enters. And then a little hole going kind of in between the two going off to the side. Okay. That would be your coronary sinus. Okay. Papillary muscles, we covered those. Those are the little bumps where all the chordae tendineae attach to. Papillary muscle here, papillary muscle there, papillary muscle there. Chordae tendineae, we talked about that. Left atrioventricular valve, or the bicuspid valve, is the one simply, so tricuspid, remember, is between the right atrium ventricle. The bicuspid is going to be between the left atrium ventricle, and you can really see it here. That's bicuspid valve cusp. This is it over here on the other side right there. Okay? And then we will not do any microscopic anatomy. So those are all the structures that you need to look at. You with me? We good? So I would familiarize yourself with this on the sheep brains, because we'll have some pictures, but we'll also have sheep brains setting out. And then when you're done, you're free to go. Okay? It's usually a shorter lab.